Hello students, in this video we will be discussing about reflection of sound. Students, in the case of light, we have already studied about reflection of light, and here the laws of reflection of sound is similar to the laws of reflection of light. What happens students, suppose if we have a wall, let us consider this is a wall in which the sound is about to strike. This is a wall in which the sound is about to strike. And let us consider we have a hollowed pipe over here through which we will try to incident the sound. Let us consider we are incidenting the sound in this direction. What happens then? It will strike the wall and it will be reflected. It will be reflected and we will be able to hear the sound from here. Let us consider we have a hollowed pipe so that we can get the directions pipe in a single direction, and if we allow the sound to pass through here, it will be incident on the wall and it will reflect from a direction, and that direction from where it is reflected, we can put our ear over here and we can listen to it. So what happened over here is, let us consider the same thing that we are removing the pipe to draw a simpler diagram. Let us consider this was the wall, this was the incident, this was the direction in which the sound was incident, and this was the direction in which the sound was reflected. And suppose student, this is the plane, and from here if we draw the normal of it, what happens? This angle between the incidence of the sound and the normal is known as angle of incidence, and the angle formed between the reflected ray of the sound and the normal is known as the angle of reflection. The first law says that the incident ray of the sound, the normal and the reflected ray and the reflected sound all lie in the same plane. All these three, one incidence, second the normal, third the reflected, all lie in the same plane. They all lie in the same plane. So this was the first law. And second law says that the incidence, the angle of incidence is equals to the angle of reflection. Angle of incidence is equal to the angle of reflection. These are the two laws that we study in the case of light as well. There we study as the laws of reflection in case of light, and here we are studying the laws of reflection in case of sound. Now, in the reflection of sound case, we will study few more things. One is echo and the other thing is reverberation. Echo, students, what happens when you stand, in front or in between two huge walls or two, hills or two mountains. There if you shout something loudly, then you will be listening the same voice again after few seconds, and that returning of the sound that you are listening after few seconds is known as echo, that we will discussing now. Now students, we will be discussing about echo. Now what is echo? Echo is nothing other than the reflection of sound. Suppose we are shouting. If we are shouting in closer to any huge hill or any mountain, then we will see that after few seconds the sound comes back. The same sound comes back, and this same sound which is coming back is called as echo. This is nothing other than echo, the reflection of the sound after some times. Now what happens, students? Now when we hear any sound, the brain persists it. It means the sound remains in our brain, for around 0.1 second. Okay? So any sound that we hear remains in our brain for around 0.1 second. And that is why the minimum distance or some minimum time, the minimum time required for any echo, the minimum time required for any echo should be, it should be around 0.1 seconds only. Okay? 0.1 second. I mean, this is the minimum time. If we, shout, and that should be there should be enough time of 0.1 second so that the sound could go and strike into any of the wall and it could come back. So the minimum time it should need is from incidents to coming back to the source or the ear, it should be around 0.1 second. And here we know, students, similarly to find the minimum distance, what should be the minimum distance of the wall from the source of the sound for the echo to happen. So we will be finding it now. Let us consider, we know that the sound of the speed of the sound in air at 22 degrees Celsius, this is the normal condition we are discussing, at 22 degrees Celsius is around 344 meters per second. And here, students, we have already discussed the minimum time for the echo should be around 0.1 seconds. So we know that the distance traveled is equals to speed multiplied by time, and here speed is equals to 344 multiplied by time is around 0.1 second. So the final answer, the final distance should be 34.4 meters. This is the total distance that the sound is covering from the source to the wall and again coming back to the ears. This is the total distance that the sound is covering. Let us consider from here the sound is being, incidence, and it is going and striking a wall which is at a distance x meters from it, from the source of the sound. And after striking the wall, it is coming back. Again, it is traveling the x distance. Therefore, the total distance traveled, the total distance that the sound traveled is around 2x. This is x plus x, 2x. So therefore, to find the minimum distance, this distance is how much? This distance is equals to 2x divided by 2, that is x. The distance between the sound and the wall. This is sound and the wall. The distance between sound and wall is 2x, the total distance, divided by 2. 2, why we are dividing it by 2? Because the sound is traveling the same distance twice. It is first going to the wall and again it is coming back to the source or the ear. So the total distance is, it is x that we have considered it. So the minimum distance for echo, the minimum distance for echo, it should be equal to 34.4 divided by 2 meters. The wall should be at this minimum distance, that is 17.2 meters. Then only if the wall is at a distance of 17.2 meters from the source of sound and the ear, then only it is possible for the sound to produce the phenomena that is echo, that it will reflect back, it will come back to our ear and we will be able to listen the same sound. Students, some same like echo, there is one more term that we will be studying now in this video, that is reverberation. Now students, what is reverberation? Just like echo, the same thing is reverberation. What is reverberation? So what happens when you are in an empty room? Empty room means in a room there is nothing. So if you shout loudly in a empty room, what will happen? You will be able to listen the sound of yourself multiple times. This multiple reflection, that is the repeated reflection of sound. This repeated reflection of sound is nothing other than reverberation. And why this repeated reflection happens? Because once it is going to the wall, then again it is moving to the other wall, maybe it is moving to the floor, maybe it is moving to the ceiling, and then again coming back. So multiple times the sound is persisting over there for a long time. Okay? The sound is persisting in the room for a longer time, and due to this there is the multiple echo kind of thing is happening, and this multiple echo or the multiple reflection of sound is termed as reverberation. Clear? Now in cinema halls also their reverberation kind of thing happens, and to reduce the phenomena of reverberation, so sound absorbents are used in the walls and in the ceilings of the cinema hall. Why sound absorbent? Sound absorbent are, kind of soft materials that are used. Why soft materials? Because harder will be the material, more will be the reflection, and softer the material, more less will be the reflection. That you might see if you throw a ball in the wall, you will see that the ball will reflect back. The wall will reflect the ball with a greater speed. But if we throw the ball in the sand, what will happen? The sand will not be able to reflect the ball with a greater speed. Why so? Because sand is slightly softer as compared to the wall. That is why in similar case, in cinema halls, the walls are harder. That is why in the walls we used to paste some fiber things or any of the soft materials that is known as sound absorbent, that does not reflect the sound with the same velocity or with the same speed. That is why sound, the energy of the sound ends after striking that sound absorbent of the soft material. Students, with this, the reflection of sound, we can use this reflection phenomena in the many things. For example, let us consider, you might have seen the sound horns. The honks or whatever it is called. What happens? Suppose we have a point source from where we are shouting. If we are shouting, the sound is moving to all the directions, and the energy is being transmitted to all the directions, and that is why the sound is not able to travel a larger distance. Now, due to this transfer of energy in all the directions, the sound is not able to move to a larger distance. To reduce this, what we do, we used to draw or make an instrument which reflect all the sounds in a single particular direction. And if all the energy is being transmitted into a single direction, then what will happen? The sound will be able to travel a larger distance. And this is the phenomena that we have used, because we know that sound follows the reflection phenomena. And because of reflection thing, we have made this kind of materials so that the sound can travel a larger distance. Again, students, you might have seen the doctors using stethoscope. In a stethoscope, what happens there? The doctor used to put one part to the body of the patient and the other part to the ear. And stethoscope used to have a pipe kind of structure, and here from the body the sound moves to multiple reflection, and ultimately it goes to the ears of the doctor. And this is also due to the phenomena of reflection. And again, students, in cinema halls there are huge sound boards used, and due to this, what happens? When the sound strikes it moves to the multiple corners of the cinema hall. And due to these sound bars only, this is sound bar, and due to these sound bars only, what happens? The sound of the movie or the whatever is being played on the wall is transmitted to the whole part of the cinema hall, to the every corner of the cinema hall. So that's it with the reflection of the sound part. Thank you very much for watching the video.